of different functions, but they all are not very complicated, so we're going to do them all. So exponential functions, so any function with power x, it's called exponential. So we're going to graph different versions of it and see the differences between them. So we'll look at the first one, 2 to the power x. You can use your calculator to substitute -2 into 2. So write 2 to the power of -2. You should get a quarter, which is 0.25. And then do another one, substitute -1 in. You get 0.5. And keep doing until you get all the values. So you get 1, 2. So you keep doubling, right? 2 to the power x doubles each time. It doubles the y values. And if we plot the points, let's see what we get. So this is 2 to the power x. So let's plot the points 0, 1, 2, 3, 4. X, -1, -2. This is 2, 4, 6, 8. Okay, let's try to graph it. 3 is 8. And then you got 2 is 4. 1 is 2. 0 is 1. And gets half each time. Right? So we plot these points. And we're going to join the dots together, which you will get a curve. Alright, let's try to do that. So you get a curve like this. So call this the exponential curve. Alright, so this is the graph y equals to the 2 to the power of x. Alright, so copy this down. Let me enlarge the screen so you can see both the table and the graph. Alright. The 2 to the power x graph goes up very quickly. That's the x-axis, that's the y-axis. And it keeps going down, isn't it? Does it ever reach 0? Never, because if you keep halving, there's always one piece left, right? Halving, halving, halving. So half of 2 is 1, half of 1 is half, half of half is a quarter, half of a quarter is 1/8. You never finish, right? It just gets smaller and smaller. So for that reason, like hyperbola, it has what we call an asymptote. So it has the x-axis is called the asymptote of the curve. Okay, so there's an asymptote here. So it approaches but never touch. Unlike hyperbola, it has only got one asymptote, a horizontal one. It doesn't have a vertical asymptote. And it can also write down its domain and the range. Domain is all real. X, range, what will range be? Above 0. Well done. Y bigger than 0. Cool. That's done. Okay, now can you try the next one where the power has changed a little bit, where the x is changed to -x. Okay? Alright, just do that. And let's see the effect, what the effect it has on the graph. Alright, let's look at this. Okay, so 2 to the power -x, you substitute -3, you should get 8, 4, 2, 1. It looks like you keep halving, isn't it? There's some experience. 0.5, 0.25. So it looks like go reverse, isn't it? When you have a -x, it goes in the opposite direction. Let's try to plot the points. I will use a different color pen, like a green pen. You will look something like this. Oh yeah, I should show that to you. Yep, that's no problem. So what you do is you press the button, you go 2 to the power of negative. It's always a negative, and then you substitute -3. So you write bracket -3. Okay, 8. Right, so there's a double negative, they cancel. That's why I end up getting 8. Alright, and same thing, once you do that, you just edit, put 2 in, -2, you get 4. And then substitute -1, you get 2. Right? But if you substitute 1, you get 0.5. Okay, so we've got these points, so let's plot them on the graph. So it gets smaller and smaller, it gets keep halving. So it goes in the opposite direction, isn't it? But it has the same asymptote. Let's try to draw it. Okay, there's your graph. And I'm going to label that as y equal to 2 to the power negative x. So now you know what the negative x do to the graph. Looks like it reflects about the y-axis. And there's a block, there's a part here you can do that. So let me just explain that. So if you see the bottom part, if f of x equal to 2 to the power x, if you substitute negative x in, it becomes 2 to the power of negative x. So that x there change to negative x. So what you do next is, so in general, whenever you change x to a negative x, it has the effect of reflecting that about the y-axis. Okay. Okay, so we drew this part. What else are there? There's one more. We're going to draw 3 to the power x. What if I change the base 2 to 3? What effect it has on the graph? So one way to find out is to draw it. So find the table, do a table of values. So you get negative 2, which is 1 over 9, 0 0.1, 0 0.3. Again, using your calculator. 1. So notice that they all have 1. Anything to the power 0 is 1. Okay. And then when 1 is 3, 9, and then 2.5, we can use a calculator. 3 to the power 2.5, you will get 15.5, which is about 16. Oh, not on the graph. Okay, good. All right, so we ran out of space, but that's okay. We can plot these points. I'm going to use a purple pen to draw it. So let's try to draw. Cross at this point, and then 3, and then 9. Goes up very quickly. And then next one is 2.5 about here. Okay, good. And then 1/3 below, and then below. Alright, so notice that it's below the blue curve and goes upward. Right? And then goes above. Let me rub this off a bit, way too much left. Alright, oh, still no good. I think a bit better. Okay, this is y equal to 3 to the power x. So you see that all the exponential graph with different bases look very similar, except that it's just a little bit steeper, isn't it? So if you have a bigger number, it gets a bit steeper. But notice that it increases fast, it also decreases fast. So when it reaches 1, the purple curve is below the blue curve, isn't it? So it's not always above, it's only above after 1, after 0. Alright, get the idea? Alright, so note the differences and similarity between them. Okay, what else I want to say? Yeah, that's the exponential graph. So remember the shape. You're not recommended to do a table of values each time because that will take a long time to do. So you just remember the shape, just get a couple points and then draw it. And remember there's a asymptote there. Okay, horizontal asymptote. Alright, what else I have to say? Domain range, they all have the same thing. Yep, let's do this. They all have the same, at least for these questions. Now, before I move on, there's another thing I want to talk about, which is, what if you put a negative in front of fx? When you put negative in front of fx, it reflects about the x-axis. And how do I know that? One way to remember this is, if fx is x squared, which is the parabola, and if we have negative fx, which is negative x squared, you have a concave down parabola, right? So it's like reflected about the x-axis, that negative. Reflect about the x-axis. Alright, get the idea? Whereas if I change the x to negative x, this reflects about the y-axis, as you see on the exponential. Right? Alright, any other questions? So that's exponential. We're now going to explore other curves. So we're going to look at logarithmic curves, square root curve, quartic and cubic. And then we're going to do a mixture of the graph. And then what's this? And then some other things. Okay, alright, let's move on. Okay, all good. Let's move on to the next page. Alright, what do we have here? Log functions. There are log you haven't learned last year, but that's still you can access that button on the calculator. See the button has a log. See the log there? That log, okay? Log. So let's put that on the calculator. -2, it will give you an error because you don't have -2. Can you have -1? Also not possible, I think. Doesn't work. Will 0 work? Will 0 work? Well, that's why I go through the table. It's in the textbook. So that's you can't do. But how about 0.1? I know you haven't done it. That's why I'm showing you. Yeah, I know you haven't done it, so we'll just do the table. Okay. All right, do log 0.1, -1. And then we'll just plot the points, see what the graph look like. 0.5, -0.3. And then put 1 in. You get 0. And then put 2. 0.3. 0.47. Yep, very good. 0.5. Round to 1 decimal place. 4.6. Nice. Okay, let's plot these points on the graph, see what we get. We got the x and y axis, so alright, okay, so it can get a bit tricky. Let me try my best. So at 1 is 0, and then at 2 is 0.3, just up a little bit, and then at 3 is 0.5, and then 0.6. Okay, and then at 0.1 is -1. Okay, so we just join the dots together, and we're going to do something like this. Ooh, like that. So it has what we have, an asymptote as well. It has a vertical asymptote at 0. Now, if you're curious what log means, I will go through its definition with you. You learned that in year 12, but in year 11 we should be familiar with the logarithmic graph because it will be useful later on in year 12. So at this point, we just want to have a quick, brief understanding of the logarithmic graph. We just need to know the shape. It looks like this. Okay. All right. And then we're going to go through where does this shape come from. Okay. Right. Yep. Morning. Let's go through its meaning if you're interested. Okay. So what does log mean? It's really mean. Let's say we've got 10. Watch this. 10 to the power of 2. What's 10 to the power of 2? 100. Okay. Actually, let's pick a better number. -1. 1/10, which is 0.1. Now, what does log mean? Let me write this together. Log means this. We're going to make the index the subject. So that's the index equal log base 10, because that's the base. So the big number becomes a small. The small little index becomes a big because it's the index, which is 0.1. Okay, right? Now, that's why log of 0.1 is -1, right? Because 10 to the power of -1 becomes 0.1. Yes, yes. So the log button on your calculator means, so when you press the log button, it means log base 10. So now, if you look at the next one, y is 1, 0, because 10 to the power of 0 equals to 1. And if you write it in this log form, log 1 is 0. All right, that's what that means. Okay, so you just need to remember the shape. It has a vertical asymptote. Looks like this. Okay. Now, for your information, it is actually related to the curve 10 to the power x, right? So if I draw y equal to 10 to the power x, it's like exponential, right? And can you see it's a reflection of this? Can you see it's a reflection? Reflection. Y equal to log base 10x. Alright, so they are sort of related in this way. We'll learn more about that next year, but now just remember the shape of the log. It's related to the exponential. Yeah. Okay, let's move on. Square root graph. Okay, can you fill in the numbers? 0, square root of 0.5, I think it's 0.7, 0.7, put 1 in, put 1, 2, 3, 4. Okay, let's plot the points. Plot the points. Class 7. Getting what? Ah. Good. Okay. Let's show this picture again. It's a square root graph. 1, 2, 3, 4, 5, 6. Okay. Enough. That's good. Alright, let's move on to this. Cubic graph. Don't know why there's a negative. I need to remove it. Okay. Negative 2. You get negative 8. Negative 1. Quartic is power 4. Quartic, cubic. Oh, now you know. Alright, so quintic is power 5. Yeah, queen is 5. What's alive? Ah, hang on. That's power 3. Power of 3. Okay, negative 3.4, round to 1 decimal place. 0.5. 0.1. Okay, good. So fill this out. Draw the graph. You should use your calculator to do it. Okay, have a try. 1, 2, 3. Okay, so we've got this. Just go up by 2, so you don't have to write a lot of numbers. Okay, let's try to do this. 1 cube is 1, 2 cube is 8. Goes up very fast. Oh, hang on. That's wrong. Yeah, oops. So it's, yeah. And then somewhere in between 0.1 and 3.4. 3.4 is here, 3.4, 0.1. Okay, something like this. Join the dots, see what you get. Yep. 0.1. Because 0.125 around to 1 decimal place. Yeah, 0.1, which is what I wrote. 0.1. Yeah. You can use a calculator. So use a calculator to work out. Alright, so we got this. Yeah, it's like an off function. It's an off function. functions. Yeah. Okay, good. What else are there? Okay, let's draw the other one, which is the green. The negative, if you do it on a calculator, this is how you do it. Put a negative, put a bracket, -2, close bracket, cube, you will get positive. Okay, 8. And then 3.4, 1.1, so you get the opposite. Okay, and you plot the points, you get the other cubic graph. No, you can do it on a calculator. Have a try. No, I don't want you to copy. I want you to actually do it and know how to do it. That's right. Good. If you're not even willing to put it on a calculator, I don't know what you want to do. Okay, all drawn. I'm going to leave it on for a minute or so. X power 4, so you go to -2 to power 4, you'd be positive 16. And then this one will be 1, 0, 1, 16. And then use your calculator for the rest. Notice that when it's a power 4, the negative just disappears. So you go -1.5 to the power of 4. 5 point something. Just put 5. And what's the other one? It will be very small. Because if you don't, it doesn't give you. Say for example, if I do -2 to the power of 4, it gives you -16. But if you put a bracket around it, you will actually raise -2 to the power of 4. Give you positive. You always put a bracket whenever you substitute into a polynomial. You always put a bracket. Okay? Alright, good. Excellent. Okay, what's the next? What was the other one? That's almost 0. 0.06, so about 0.1. 5. Okay, let's plot the points. I want to draw it over here. Now, why do I draw the parabola here? So you can compare with the parabola. This is y equal to x squared, right? Y equal to x squared. Let's draw y equal to x power 4. I want you to see the differences between them. So 1, 2, 3, x. Put a dot there. 2 is 16. And then 1.5 is about 5. 2, 4, 5. Something like that. Okay, good. I need to make this a bit bigger. So it's below the graph, something like this. And then you keep going up. Ooh, this is a bit harder. It is hard to draw. You use a pencil. I know. So you need to do a bit more practice at home. Once you draw something like that. That's your graph. Let me enlarge this. So it looks like this. So it's very steep, isn't it, compared to the parabola? It looks like a parabola, but it's very steep when the power is raised to the power of 4. Looks like that. Yeah. So one looks like this, right? One parabola looks like this. Can you see the difference? Parabola. This one's very steep. That's that. Okay. Actually, I've got a program called Desmos, so I'm going to show you. The computer can draw better than me. Let's freeze that. Going to be parabola. You should be able to draw it. Let's draw it. Easy like this. Oops, that looks bad. Yeah, I know. I got a bad pen. It's not very nice. Alright, let's put a dot there. Okay, that's your parabola. Now when you draw a parabola, make sure you plot a point. When x is 1, y is 1. Okay, 1, 1. Okay, good. How about the next one? Do you remember what the next one is? It's a cubic. We just did that. It looks like this. Right? Cubic. Which is also pass through 1, 1. Yep. Square root of x looks like an upside down sideways parabola. So you get 1, 1 as well. Pass through. They all pass through 1, 1. Most of these. Now what's the next one? Remember what the next one is? Circle radius 4. Okay. Radius 4. Okay, I'll slow down after this. Make sure label x and y axis. Okay, have a try. So you're up to this one. That's a semicircle. Just remember there's a square root. Note the difference between this one. That's a square root graph, not a semicircle, but this one have an x squared inside. 9 minus x squared, that's a semicircle of radius 3. And it's an upper semicircle. Okay? Remember what this one is. We did that last lesson. The hyperbola. Now, see the negative? You have to go that way. And also you have to indicate a point. So when x is 1, what's y equal to? Negative 3. So plot that point. 1, negative 3. You need to indicate at least one point on the graph. Yeah. Let me write this carefully. Alright, 1, negative 3. Okay, good. See if you remember the next one. Who remembers this one? What does this one look like? Not straight line. X, y equal to 2. It's a hyperbola. If you make x the y the subject, goes this way, it's positive. Okay. Again, indicate a point on the graph. 1, 2. Well, it's all on one page. That will help you to remember better. How about the next one? X plus y equal to 2. It is a straight line. What's the x and y intercept? You can find the x and y intercept when y is 0. What's x equal to? 2. And when x is 0, what's y equal to? 2 as well. Find the x and y intercept. Join the 2 dots. You get a straight line. See the difference between these two? When you change times to a plus, you get a completely different shape. Alright. And 4 more. Can you finish them off? Okay, I'll just freeze this. And then I will just pause the video. Exponential, let's draw the exponential. But remember that negative, what does the negative do? Goes down the other way, right? Pass through 1. And also indicate a point on there. When x is -1, y is 3. Indicate a point there. And it has this asymptote, which you should indicate. Oh, sorry. Yeah. And then you got this. This has got 2 asymptotes. Alright, more -2. See if you remember these ones. It has exponential curves on it as well. Doesn't work? Too big. Alright, okay. My graphs may be too small. Anyway, but in the exam you draw your own size grid, so you can make it work on the blank piece of paper. Okay, next one. Y. Yep.
I don't understand where you're
Alright. Next one, -2. -2. What shape is that? Horizontal line. Okay. How about x equal to 2? Vertical line. How about the last one? See if you remember. Alright, who knows the last one? No. Do you know why it's not hyperbola? Because this x is not in the denominator. It's on the top. It looks like it's a hyperbola, but it's not. It's a straight line. If you write it like this, it's 1/3 of x. Right? You pass through the origin. And you pass through the point when x is 3, y equal to 1. It's a straight line. Note the difference. Alright. One more page, then we're done. And we'll get some pie ready. Okay, let's move on. Looks like it's all finished. Thank you. Let's move on. Alright, let's move on to the next bit. Now, we need to know how to shift and reflect graphs. Okay, so we need to know that this plus k, shift, k units. Oh, hang on. No, I'm supposed to substitute. So, listen, x plus k, what do you get? What do you get? You get x plus k squared plus h. Yeah. X plus k squared plus h. Can you see that when I substitute x plus k, the x there inside the square change to x plus k. Now remember this parabola, what does the k do? It horizontally, k units, left or right. What does h do? Up or down. Okay? So whenever you see this, you know it's a horizontal shift. So let's write a summary. When you go plus k, you shift horizontally. Shift horizontally, k units. Left or right depends on whether k is positive or negative. So plus h is going to shift vertically. Up, shift vertically. K unit, h units. And then y is negative x, reflect the graph of y equal to fx. Correct. So if I could write it here. So k negative will be right, k positive will be right, left. And this be h positive up, h negative down. Very nice, good. Okay, so what else I should say? Now remember, what does this do? The negative x, you reflect about y-axis. And the other one you reflect about x-axis. Alright, now we're going to apply this rule to sketch these graphs. They all involve the transformation mentioned above, either shifting or reflecting. Okay, so you need to know how to shift graph, how to reflect graph. And that will be done on these examples. Okay, so hopefully you can recognize this. So that's a square root graph. So what's the difference between them? What does the negative x do? Reflect about which axis? X-axis, no, y-axis, right? This negative x, reflect about y-axis. So they go like this. So if I have f of x equal to root x, the f of negative x is root negative x, right? So it's a reflection about the y-axis. So it goes like this. And it passes through the point negative 1, 1. Mm-hmm. Yeah, we can move on the whole lesson, but I won't do that to you. Alright. Okay, let's move on now. How about the next one? What type of graph would it be? 2 to the power x. It is a exponential. So now again, let's look at it very carefully. You can write this as negative 2 to the power x plus 3. So what does the plus 3 do? Up 3. Because you're adding the k to the function, not to the x. So it's not x plus k, it's fx plus k. Now, how about this? What does the negative do? Reflect about x-axis. Yes? So that means when you draw this, you're going to draw this graph. Right? So draw this graph instead of this one. Remember what exponential look like? So normally, let me draw it here. So if I draw 2 to the power x, it looks like this. What does negative 2 to the power x looks like, the extra negative? It goes like that, right? Yes? So the negative reflect the graph about the x-axis. So now we're going to shift this graph up 3 units. So we're going to shift this up 3 units. So this is negative 1. If you shift up 3 units, 1, 2, you will pass through 2. Like that. That's your graph. Shift up 3 units. Alright, go one more. Okay, hopefully all done. I'll just show you that connection between the negative. See the negative 2 to power x. Yeah, you don't need a, but you need to know how to get the blue one. I'll get rid of this. So you need to draw the graph of negative 2x. Negative 2 to power x. Let me rub this off. Okay, so now it looks clearer. Yep. One more question, then we can really finish. Alright, who knows how the next one works? Think about it. Think about what the components do to the graph. The negative, the +2. Yep. Say again. Very good. You reflect about the x-axis because of the negative. How about the +2? What does the +2 do? Very good. Left 2 units. Now, what shape is the square root? Looks like this, right? So you have to draw a square root graph. So that would have been a negative square root. And then when you shift left 2 units, it goes like this, right? Okay, so let me rub this off because you get confused with too many lines. Alright, so we'll just draw this bit. Negative 2. Right, negative 2x, y. Okay. You can find out what the y-intercept is. That will be square root of 2. X is 0. Alright, got it? How it works? Exercise 5.9, do all. Questions? Yep. So while you're waiting, can you get started with the exercise? Yep.